All right, so as promised, we're talking about concavity. We're looking at the second derivative, and we have gone through some of these questions, and we've looked at how the first derivative tells us whether a function f is increasing or decreasing. And then we talked about how our second derivative, right here, can also tell us if something is concave up and concave down, because it connects to how the first derivative is either increasing or decreasing. We've done a bunch of graphical analyses on these, but what I want to do is go through and show you how this works in an analytic sense. So looking at the first question, the first two are pretty standard operating things. We've done these now quite a bit. The first one says find the interval for which f is increasing or decreasing. Well, to find f is increasing or decreasing, we need to look at f prime. So we take the derivative of f to get 4x to the third minus 12x squared. And we need to set that equal to 0 because we're looking for critical points. We need to figure out where's the positives versus the negatives. That looks hard to solve. So I'm going to factor out a 4x squared. And we'll get x minus 2, or minus 3, my apologies, is equal to 0. And we find out we get critical numbers at 0 and at 3. From there, we're going to set up our line chart focusing on f prime. Remember that this line chart is going to show us the sign values for f prime. So we're going to look at that. If we plug in a negative number in here, this becomes a positive. This stays negative, so we get negative. If we cross over the 0, that's where this changes, but since that's squared, there's no sign change. And then there is a sign change when we cross over the 3, so we get a positive. And we get f prime here. And now that we have f prime, we can actually answer parts A and B, because A wants to know when is a function increasing or decreasing. So a function is increasing when f prime is positive. So f is going to increase on 3 to infinity, since f prime is positive. And f is going to decrease. Now you could say this two different ways. For the sake of laziness, I'm going to say from negative infinity to 3. Technically, I could say from negative infinity up to 0 and then from 0 to 3. Both are going to be acceptable answers. And in this case, it's because f prime is negative. Part B, do that in blue, is asking for the x-coordinates for the local min and local max. So we need to know when f has a local min, f has a local max. So I look at that. Again, this is another f prime question. So f has a local min when f prime changes from negative to positive. That only happens at x equals 3. F prime changes from negative to positive. And for local max is when f prime changes from positive to negative, and you'll notice that doesn't happen. So this actually has none. F prime does not change from plus to minus. Last but not least, we have part C here. Part C, we're dealing with intervals of concavity. So the first thought is to deal with the idea that when the derivative is increasing, we find out that there is a min or a max. So if I look at my sign chart here, there's no way I can tell whether f prime is... I know it definitely increased somewhere around here from 3 because we went from a negative to a positive. But what I don't know is when did this make a turn to go from being a decreasing graph to being an increasing graph. So what I'm going to have to do is I'm going to have to evaluate now not just f prime, but now I have to find f double prime of x. So I go back over here to f prime of x, and I take that derivative, 12x squared minus 24x, and I'm going to set this equal to 0. Now, I'm not going to call this critical numbers. I'll talk about this in just a second. We get 12x here. This is x minus 2 equals 0. So now we have possible points of inflection, and that's what they're going to be called. Are going to be called possible points of inflection are going to occur at x is equal to 0 and 2. They're not called critical points because the critical point is specific to f prime. Possible points of inflection are specific to f double prime. So it seems like it's not a very important change, but we're going to use that. We're going to be consistent with it. So now I'm going to look at a new chart, but now instead of f prime, now I'm looking at f double prime between 0 and 2. If I pick a negative number, both of those will be negative, so I get a positive. This will be a negative. This will be a positive. So now I need to figure out the intervals of concavity, of which there are, there's concave up. So f is concave up from negative infinity to 0 and 2 to infinity, because f double prime is positive. And f is concave down now from 0 to 2, since f double prime is negative. So that's concavity, but then I need to find inflection points. So inflection points happen when the sign change occurs here. So we know that x equals 0 is an inflection point since f prime changes. And I want to find the points. So I want to actually go back to here, and I'm running out of space, but we'll do what we can do. So when x is equal to 0, we know we've got the point, when x is equal to 0, we know we have the point 0, comma, f of 0. So if I go back to my f function and plug this in, this occurs at the point 0, 0. And when x is equal to 2, there's another change in sign here, so there's a concavity change there. We're going to look at the point 2, f of 2. And when we substitute in those values, I had it worked somewhere. Haha, there it is. All right, so 2, negative 16. And what I did is I substituted the 0 and the 2 back into my f function because these are points on f. And so these are my points of inflection. Taking a look at a different example then, number 2, same exact concept, same exact thing going on. We're going to find increasing, decreasing, x's of mins and max, and then intervals of concavity and inflection points. First we have to find, I did this in red first, I need to find f prime of x, which in this case is going to be a little bit gross. 3e to the x plus 3x e to the x, and set this equal to 0. I have an 3e to the x I can factor out, leaving me with 1 plus x, which means I have a single critical point at x equals negative 1. I make my sign chart, negative 1 right here. And when I plug in a value smaller than negative 1, we get a negative value to a positive value. So this is kind of nice because that means f increases on negative 1 to infinity since f prime is greater than 0. I'm going to change that a little bit instead of saying is positive. And we can say f decreases from negative infinity to negative 1 since f prime is negative. I'll tell you what, since I've got all of this and I'm going to just use this f prime graph to come up with the relative min and max, I look and I only change from a negative to the positive, which means the only thing I really have is a relative min at x equals negative 1 since f prime changes from negative to positive. So that's all old first derivative stuff. Now we take a look at second derivative work. Give myself a little more room here. And if we take f double prime of x, now this gets fun because now we have this 3e to the x. So the derivative of 3e to the x is 3e to the x. My favorite here is that I get a 3xe to the x. So I'm going to have to product rule that. But if I'm really smart, I'll recognize that I already did this once. So the derivative of this is 3e to the x plus 3xe to the x. So I'm just going to copy that down, because why do more work if you don't have to? We're going to need to set that equal to 0. So I'm going to simplify this a little bit. Yes, 3e to the x plus 3e to the x is 6e to the x plus 3xe to the x, which is 0. And I can divide out a 3e to the x to get 2 plus x equals 0. And now my possible point of inflection is at x equals negative 2. Label this. I did not label that. Let me label this over here real quick. I apologize. So this is my f double prime. So I would have plugged this number back into this equation right here to see whether it's positive or negative. And I need to come up with concave up and concave down. That's pretty easy. Concave up is going to be from negative 2 to infinity, since f double prime is greater than 0. This is concave down from negative infinity to negative 2, since f double prime is less than 0. There's only one possible point of inflection. So a point of inflection is going to occur, and sometimes I'll abbreviate that POI, is going to occur at the point negative 2 f of negative 2. So I need to substitute that in. That's negative 2, and if I substitute in a negative 2 here, this becomes negative 6, 3 times negative 2, e to the negative 2. And that's a specific point. We could do the same thing for the relative min. For those of you that are curious, we could actually find the point, but the question didn't call for the point. Notice the difference. X-coordinates of the local max and min versus the inflection point, which is the entire XY combination. That's 12 minutes. That seems like enough time to talk about those two questions. Feel free to make sure to write down questions you have for tomorrow. Make sure to answer the two questions here at the bottom. Down here, you should be able to attempt to draw this sketch and to answer this multiple choice question so that we can see how you did on those, ask questions about that, and get to board work tomorrow. Have a good day, and I will see you all tomorrow.